Okay, this is the recap episode for solving triangles using the ambiguous case. So just really quickly, I want to go over how we figure out how many triangles there are possible, and then I'm going to go over two examples of ambiguous case triangles. So if I give you an acute angle in a triangle where we're using the sine law, we want you to solve the problem normally, and then you check to see if sine theta works. So if sine theta is too big, if it's greater than 1, or if it's too small, less than -1, it means there's no triangles. And if you try to punch in sine inverse of a number that's bigger than 1 or less than -1, you'll get an error. Okay, so there's no triangles. If sine theta equals 1 or -1, that means it's a right angle triangle. And if sine theta is between -1 and 1, that means we have two triangles. So we have the ambiguous case, and you have to solve both of them instead of having just one triangle. If you're given an obtuse angle, you solve the problem like you normally would. And if sine theta is bigger than 1 or less than -1, there's no triangles. And for obtuse angles, if sine theta is in between -1 and 1, then there's only one triangle. So there is no ambiguous case if you're given an obtuse angle. So for the first example, we want to determine how many triangles are possible. We don't have to actually solve, we just have to figure out how many are possible. So the first thing you want to do is just make sure you have all of your values in the right spot. So we have angle y is 56, and side y, which is this side over here, is 22, and our other side is 25 meters. So we'll set up the sine law. So we're looking for angle z, which is across from side z. So sine z over 25 equals sine y over 22. Okay, so we're just going to multiply 25 times sine 56 divided by 22 and see what we get for sine z. Okay, and then we can determine how many triangles there are. So if we do 25 times sine 56 divided by 22, we should get 0.9 on our calculator, which means that sine z is in between -1 and 1. Okay, so because sine z is 0.9, which is between -1 and 1, okay, that means there are two triangles. So we don't have to actually solve them, but we could if we were asked to. In the second example, we're asked to solve the following triangle. So first thing we want to do is check to make sure there is a triangle, and then as long as there is one, we're going to solve it. So in this case, we're given an obtuse angle, 130 degrees. Okay, and we know that side S is 50 and side T is 20. So what we have to figure out is, will side S connect over here and make a triangle? And because we have to solve the following triangle anyways, we may as well set up the sine law to double check. So we set up our sine law the same as the last example. So sine of angle T over 20 equals sine of angle S divided by 50. Okay, so if you multiply 20 by sine 130 divided by 50, you end up with 0.3. Okay, and some more numbers. So what this means is we have we have one triangle because it's obtuse. Okay, so because this works out, 0.3 is between -1 and 1. We're going to have one triangle, so now we can actually solve for angle T. and that will enable us to solve for the other missing angle and the other missing side. So what we have is a triangle that looks like this. Okay, we know this angle is 130. We know this side is 50. And this side is 20. And what we need to do is solve for angle T by doing sine inverse. Then we can find angle R, and then we can find side R, because the question's asking us to solve. So to find angle T, we use our sine inverse. So angle T is 18 degrees. Which means angle R will be 180 minus 130 minus 18. So angle R is going to be 32 degrees. Okay, and our last step is to find side R, which is over here, our third side of our triangle. So to find side R, you could use sine law, you could use cosine law. Either way should get you the right answer. Okay, I'm going to use sine law to solve for angle R, or sorry, for side R. So we have side R, which is across from angle R. Okay, and then we can use either pair here. I'm going to use the pair given in the question. So we have 50 and sine 130. Okay, so if I multiply, I find my third side is 34.6 centimeters. Okay, so you want to finish everything off with what you found. So therefore, angle T equals 18 degrees, angle R equals 32 degrees, and side R equals 34.6 centimeters.